The absolute value function is actually defined as a piecewise function with two linear pieces. So on the right side of our graph, we have a line that has a slope of +1, and on the left side of our graph, a line with a slope of -1. So these two pieces together give us the V-shaped graph that we're used to seeing for our absolute value function. We can also think of absolute value as a distance between numbers on a number line. Because we're thinking about this as a distance, the distance between any two numbers will always be a positive quantity. So when we take the absolute value of a number, whether that number is positive or negative, because we're thinking distance, we'll always receive a positive answer. So let's look at a couple of different statements and see if we can write these as absolute value statements using this idea of distance. So first, let's think about the set of numbers that are less than 1 unit away from 0 on the number line. So if we were to draw a number line here, imagine 0 being in the middle of our number line here. And think about being 1 unit away from 0. So you could go 1 unit to the right, but you could also go 1 unit to the left. So this distance between 0 and 1 is 1 unit. So thinking about the values, we could call it a variable x that would satisfy being in the set of numbers less than 1 unit away from 0. We need numbers that are less than 1, and we also could have numbers that are greater than -1. So any number that's less than 1 and is greater than -1 will be less than 1 unit away from 0. So we could write this as two inequalities with an and statement. We could also write this using a three-part inequality to show that x, this number, must be in between -1 and +1. So as an absolute value, the way that we can write this statement to show that our number needs to be less than 1 and greater than -1 is to say that the absolute value of x must be less than 1. Because as we think about negative numbers, for example, -1/2, the absolute value of -1/2 is +1/2. 1/2 is less than 1. But if we had, say, +3/4, the absolute value of 3/4 is 3/4, which is still less than 1. So what if instead of saying less than, we thought about a statement that said exactly? So the set of numbers that is exactly 6 units away from 0. Let's start with a picture again. So we're still thinking about a distance from 0. So 6 units to the right would give us +6. 6 units to the left would give us -6. So this time we're just thinking about being at those exact specific values because we need to be exactly 6 units away. So this distance from 0 to 6 is 6 units. So one possibility is that x could be equal to +6. The other possibility is that x could be equal to -6. So thinking about how we could write this as an absolute value, this time instead of an inequality, we're going to write an equation. We could say that the absolute value of x is equal to 6. Because the absolute value of 6 is 6, the absolute value of -6 is also 6. These are both numbers that have a distance from 0 of 6 units. That's what our absolute value is telling us. So now instead of thinking about a distance from 0, what if we shift things on our number line a little bit? What if we think about the set of numbers that are 3 units away from the number 8? So let's start with a picture. So think about 8 on your number line. So 3 units away from 8, we could go 3 units to the right, and from 8 we'll go to 9, 10, 11. Or we could go 3 units to the left, 7, 6, and 5. So if we need a distance of exactly 3 units, we can go 3 units to the left or we can go 3 units to the right. So the x values that we come up with are x equals 5 and x equals 11. So now when we think about how to say this as an absolute value, we want to think about a way of saying that it's the distance between some unknown number in 8 that distance is what is equal to 3. So we'll have the absolute value of x minus 8, the distance between x and 8 needs to be equal to 3. So we can write an absolute value equation. The numbers inside of our absolute value are our unknown x and 8, and the 3 is saying that the distance between these numbers is equal to 3. So instead of exactly 3, what if we change that to more than 3? If we go back to our picture, so here's 8, we now know that 5 and 11 are key spots on our number line. So the set of numbers that is more than 3 units away from the number 8. So this was our 3 units. If you're going to be more than 3 units, you must be on the outside of that. So things that are greater than 11, or here's our 3 units to the left. Anything further away than that would be more than 3 units away. So if we think about what's shaded on our number line here, it's those x values that are less than 5 or those x values that are greater than 11. That we have 2 separate or disjoint areas of shading, and so the or is important here to say that you could be on that left side of the shading or you could be on the right side of the shading, but you'll never be able to be in both parts. As an absolute value statement, when we go to write this, we can use that same absolute value of x minus 8, because this is representing the distance between some number and 8. Now we're saying that distance needs to be greater than 3. One last one, if we switch to less than instead of more than, we can draw our same picture with 5, 8, and 11. But this time when we're thinking about that 3 units on either side, we want to be less than that. So we need to be inside of 11 and inside of 5. So now notice that our shading is all stuck in between the 5 and the 11. So similar to what we had on part A, we could say that x needs to be greater than 5 and it needs to be less than 11. It's stuck inside in between those. We could also write that as a 3-part inequality to say that x is in between 5 and 11. So as an absolute value, we would have the absolute value of x minus 8. The distance between the number and 8 needs to be less than 3. So a few things to note here as we're taking a look at what we have in our pictures. When you have an absolute value with a greater than symbol, that's when we're going to end up using the word or, and that's when we will have 2 separate areas of shading on our number line. When you have an absolute value with a less than statement, that's when we will have an and, or you can write that as a 3-part inequality, and your shading will be trapped in between 2 numbers. So the or will go with the greater than, the and will go with the less than as we're setting up our absolute value inequalities. So or gives us 2 disjoint areas of shading with the greater than, and gives us 1 single area of shading with the less than.